So let's talk about circles. If you have a full circle, it is a degree measure of 360 degrees, which most people know. If I cut a circle in half, I get a semicircle with a degree measure of 180 degrees, right? Well, what if I have this yellow part of the circle I have traced? What's that called? Well, if you have this is called an arc. If I trace a part of the outside of a circle, it's called an arc. And I have traced more than 180 degrees here, so that is called a major arc. So a major arc is more than 180. And the symbol for an arc, it's just curved. You would put that above AB. So that's my major arc AB. Well, what if I want to talk about the smaller arc from A to B? Well, that arc is less than 180 degrees, so that is going to be a minor arc. Minor arc with the symbol above it for arc AB. Now, if you take a look at that angle 1, we're going to figure out what the rule is. Now that, I can't talk and do this at the same time. I'm trying to find the eraser. Okay, I got it. I'm good. Angle 1 is called the central angle because the vertex of the angle is at the center of the circle, if you want to put the center point in there. And if you look at the theorem, basically what it says is if you have a central angle, this angle 1, it is the same degree measure as the intercepted arc. So it would be the same degree measure as this minor arc AB. So if you extend out, if you extend this out, it's the same degree measure as the arc within those two lines that I extended. So for example, if arc BA is, I don't know, looks like about 90 degrees actually, angle 1 as a central angle would be the same degree measure, 90 degrees. So let's do a problem so you can see how to do this stuff. Okay, so number 1, we have the endpoints of AOC are on circle O. Now the name of the circle is the center. So if it's called circle O, I know O is the center of the circle. The measure of angle AOB is 89 degrees, COD is 42 degrees. Okay, let's find each measure. For part A, it's actually old stuff. Sometimes you have stuff that uses theorems from earlier in the year. We want to find angle BOC. Well, can you guys tell that right here we have a straight line, right? A linear pair. So how do you find angle BOC? Well, linear pair, the angles add up to 180. So I would just do 180 degrees minus 89, and I get 91 degrees. And put the answer in the diagram as well, because sometimes you end up using that number later on. Okay, so next we want to find the measure of arc AB. Now we're going to use that central angle rule, the theorem that we talked about before. So this arc AB, it's the intercepted arc for the 89 degrees. Again, if you were to extend, I don't need that, if you were to extend out, you can see that, I'm just going to use the highlighter so you can really understand this. The intercepted arc is the arc that's in between those two lines when they're extended, which means if this central angle is 89 degrees, then that arc AB is the same degree measure, so it's also going to be 89 degrees. Now it's up to you how much you want to do in the diagram with regards to highlighting or extending out. Sometimes it can get kind of sloppy by the end, but at least so you can visually see that here. Part C, arc BC. BC is the intercepted arc to the angle that's the central angle that's 91 degrees, so it's the same degree measure, 91. Angle DOA. DOA, well, if you look here, we don't have angle DOA or the intercepted arc right in front of it, so we have to find it a different way. Well, look at this angle, like right in the center of the circle, right? We have 3 of the angles, we're missing the 4th angle. Well, all together, they would form a full circle 360. So really what we can do is we can add up those 3 angles, the 89, the 91, and the 42, and we can subtract them from 360 degrees. We get 222 when we add them together. And when you do that, you're going to have 138 degrees. That is the degree measure of angle DOA. Arc DA is next. Arc DA is the same as the central angle, 138, same degree measure. By the way, if you're wondering how do you know it's not the other way, like how do you know it's not from D all the way around to A that way, if they wanted you to go that way, they would have called it DCA or DBA, so you know you go in that direction. Otherwise, you just go the shortest distance. And the last question, arc BCD. So for this one, I'm just going to do a little highlighting. Arc BCD is all of this. So all we have to do is get those two arcs and add them together. Well, we have one of the arcs is 91, and this arc CD is 42 degrees because it's the same as the central angle. So if I do 91 plus 42, I will get 133 degrees. All right, now practice number 2. Another definition, a chord of a circle is a segment whose endpoints are points on the circle. So if I draw 2 points in the circle wherever I want and I connect them, that is called a chord. And a diameter is an example of a chord. It just happens to go through the center of the circle. Okay, one more together here. Number 3, it says if major arc AB is 310 degrees. Now, if it's a major arc, it has to be more than 180. So I'm going around all the way around from A to B the long way. First, we have to find minor arc AB. Well, minor arc is this short distance here, right? The shortest distance less than 180. If a full circle is 360, I would just do 360 minus 310, and I get 50 degrees. Next is angle BOA. Well, BOA is a central angle, and the rule is that the central angle is the same as the intercepted arc, also making it 50 degrees. Part C, maybe pause it and see if you can figure it out on your own. But what you have to do is you have to use the triangle to find angle OBA. And you might think, okay, triangle sum theorem, right? All the angles add up to 180, but we don't have 2 of the angles. So how do we find either one of them? Well, from O to B is a radius, and from O to A is a radius. And if you have 2 radii drawn within the same circle, they're congruent to each other. So if you look, if I actually draw that in, well, now I've formed an isosceles triangle. And the 2 base angles, OBA and OAB, are congruent, right? Base angles are congruent. So use triangle sum theorem, 180, subtract that angle that we have 50 degrees, and we get 130. And then, because the base angles are the same, you would just divide by 2, and you get 65 degrees. So both of those base angles are 65 degrees. So you're not going to know right away it's an isosceles triangle. You have to think about it using the radius, that they're congruent, and just then go from there. Okay, do the rest of the sheet 4 and 5.